So the warm-up today is to complete this table. It's pretty simple, right?
Yes.
So if I have 1 soda, I have 3 juices. Let's say I'm making a little fruit punch and I mix in some Mountain Dew and some Pringles, some juice. But then, unexpectedly, more people come to my party. I have to make more fruit punch. So instead, because I'm popular, instead of having 1 soda, I now have to use 2 sodas. But I don't know how many juices to use. How many juices do I use, Lucy? 6. I use a total of 6 juices. Exactly. And, oh my gosh, more people showed up at my party. Oh, this is getting crazy. How many sodas do I need here, Elsie? 3. Now, how'd you guys figure that out? How did you guys figure it out? Who wants to tell me? Romario.
So I basically did 1, 2, 3, and then for each I just like 3 to 6 times.
So is that always going to work? We can just count 1, 2, 3 and do stuff like that. That always works? Madison. Quiet.
So I saw that for soda, for every 1 soda, there's 3 juices. So when it said that we needed 2 sodas, I knew since what 3 times 2 is 6. So that's why 6.
Exactly, because our ratio is 1 to 3. We multiplied it by 2 to get to 2. So we do the same to the 3 to get to 6. Then we multiplied that 1 times 3 to get to 3. So we multiplied the 3 times 3 to get to 9. This is just ratio tables. It's exactly what we've been doing. It's very similar to unit rates. It's very similar to all of our rates. So exactly. Here, equivalent ratios. They express the same relationship. For example, as we know, if we know fractions, 1/3 is the same as 2/6, which is the same as 3/9. And we can go on forever. That's the same as 30 over 90. That's the same as 300 over 900. 3,000 over 9,000. We can just keep going forever. So, I want you guys to complete this table. Miss Diaz pet 66 cats in 12 minutes. How many did she pet in 2 minutes? So, I pet 66 cats in 12 minutes. How many did I pet in 2? So I go to 2 minutes. How do I go from 12 to 2? This is easy. How do I go from 12 to 2? Yes. Yeah, I divide it by 6. So what am I going to do to the other side? What am I going to do to the other side, Lily? Divide by 6. Hey, everybody. I'm not going to ask you to show it on your fingers because you can't. But what's 66 divided by 6? What is it? What is it, Lucy? 11. So I pet 11 cats in 2 minutes. Hey, what if I asked for this? What if I asked for this? How many did I pet in 10 minutes? How many did I pet in 10 minutes? Shh. I want you to think about that. How many did I pet in 10 minutes? Ben. So how'd you get there? So let's see. Ben says 55. Let's see if he's correct. How do I go from 2 to 10? Elsie. Times 5. So what am I going to do to the other side? What am I going to do to the other side? Also, Elsie? Times 5. Same thing. Look at how each side always has the same matching thing happening. And what is 11 times 5? What is it, Jaden? 55. Exactly. This is how we use scaling. As a question, could we have gone from 12 to 10 easily? No, I can't divide 12 by anything easy to get to 10. So sometimes we use scaling to get to something good. The easiest way to scale is to go down to 1 and then multiply up. But in some cases, we can go to 2. For example, if I asked you to go to 7, 2 is not going to work that well. So the easiest scaling is to get down to our unit rates, as we did last lesson, and then go up from there. So, let's read this question. To make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. Find the amount of sugar needed for 4 cups of cranberries. So what goes right here? What goes right there? Who can raise their hand and tell me? Rafi? 12, exactly. What goes right here? What goes on the bottom? What is it, Rocco? 16, excellent. Now, am I going to put something here or here? Am I going to put something here or here? What am I going to do? Rocco? The cranberry one, because it says 4 cups of cranberry, so I put 4. And up top, I want to know what it is. One way I can symbolize it is just with an X, because we don't know what it is. Let's think. How do we go from 16 to 4? How do we do that, Anita? Divide by 4. So at the top, what am I going to do? At the top, what am I going to do, Hannah? Divide by 4. So what am I going to get for X? What is X going to equal in this case? Let's see, Mario. 3. Our X equals 3. Exactly. So, if we figured this out, the way they want to do it too. Let's see how they want to do it. They want to do, I don't like the way they want to do it. So we're not going to do it that way. Anyway, so sometimes we need to scale to find an answer. I brought that up a little bit earlier. So let's look at this. Cans of corn are on sale at 10 cans for $4. How many are 15 cans? So in this case, can we multiply 10 to 15 easily? No, we can't. So let's think of a good number that both 10 and 15 have in common. Basically, what's a factor that they both have in common? What's a factor, Fernando? 5. That's awesome. So first I want you guys to go to 5, and then I want you guys to go to 15. So do this in your books. So, how did we get from 10 to 5? How do we get from 10 to 5, Michelle? Shh, we should not be talking, but yes, we divide it by 2. So what am I going to do? What else am I going to do, Madison?
We're going to divide 4 by 2.
Excellent, because we match on each side. We match on each side. Everybody, fingers up. What's 4 divided by 2? Fingers up. 4 divided by 2? 2. Perfect. We're done, right? No. So now what do I have to do? Now what do I have to do, Liam?
Come on, Liam.
Let's see. What do we do? Roman, what do we do?
Oh, 4. I don't know.
Let's see, Mario. We divide by 3. What do we do, Madison?
You multiply by 3.
Multiply times 3.
And you do the same for the bottom.
And I do the same for the bottom. Show me your fingers. What's 2 times 3? Yes, it's 6. So, how much do 15 cans of corn cost? How much do 15 cans of corn cost altogether? $6. Yes. So, I want you to try this one. So let's read it. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? So, first question. Is there a whole number we can multiply 14 by to get to 49? Is there? Let's think. Let's see if there's a factor. Let's see if 14 is a factor of 49. What are our factors of 49? What's our first pair of factors, Rafi?
1 and 49.
Excellent. 1 and 49. What's our second pair of factors, Romario? 7 and 7. Are there any others? 14 is not a factor, so we cannot multiply 14 to get to 49. So our answer is no, there isn't. But what we can do is do some scaling. What are we going to scale back to? What number is a good number to scale back to? Basically, we're trying to find a number that 14 and 49 have in common. What number? I know you guys are all good at this, Anita. 7. Because look, what are the factors of 14? Our first factor is 1 and 14. And our second factor is, Lucy? Yes, 7 and 2. Hey, they both have 7. So we're going to scale to 7. And then we scale forwards to what? We scale forwards to what, Madison? We scale forwards to what we're looking for, 49. So we scale forwards to 49. Perfect. I want you guys to do that. Let's see. I want to make sure. So the number of hours, we got to get to 7. So how do we go from 14 to 7? How do we go from 14 to 7? How do we do that? Divide by 2. Excellent. So we're going to divide 8 because he mows 8 lawns. We're going to divide that by 2. What's 8 divided by 2? Show me your fingers. 8 divided by 2. 8 split into 2 parts is... Who can tell me? It is 4. It's 4. So now we have to go to 49. How do we get from 7 to 49? How do we do that, Rocco? That's not correct. Not by 6. How do we do it, Hannah? By 8. How do we do it, Raphael? 7. 7. Oops. 7 times 7 is 49. That's okay, guys. So we get 7 times 7 is 49. So we're going to do the same thing to the bottom. Who can raise their hand and tell me what is 4 times 7? Emerson. 28. So our answer would be Joe can mow how many lawns in 49 hours? Madison? 28. Excellent. So I want you guys to do C on page 41 and then pick 2 of 1 through 3 on page 42. Sound good? So here's how we do C. On the chart, it already tells us there's 25 centimeters to 10 inches. And it gives us the end answer we want, the 105. Does 25 multiply to 105? No, it doesn't. So we're not going to estimate it that way, but we are going to be close. So we want to find a number that 25 and 10 have in common. What number do 25 and 10 have in common, Oleg? 5. Exactly. So we want to divide them both by 5 because that's what they have in common. So we divide them by what they have in common. What is 25 divided by 5? Number of fingers. Fingers up, fingers up. Yes, it is 5. What is 10 divided by 5? Fingers up, fingers up. Yes, it is 2. So now, how do we get from 5 to 105? We're not going to show our fingers up because it doesn't work. How do we get from 5 to 105? Daniel. 21. Exactly. A good way to think about this is how many nickels are in a dollar. How many nickels are in a dollar? Do you guys know?
20.
Jenna? How many nickels, Liam? No. How many nickels, Hannah? No. How many nickels, Rocco? 20 nickels are in a dollar. Quiet. So we have an extra nickel here, so it's 21. We're going to multiply 2 times 21. What is 2 times 21, Matthew? 42. So what is our answer? 42. 105 centimeters is approximately 42 inches. So this one's pretty easy. Let's see. It says Santiago receives an allowance of $7 every week. How much total does he receive after 4 weeks? So show us how you do it and walk us through it, Miles.
So first what I did is I did the bottom ones, which 1 to 4, and there's 2 free spaces. So I just put in 2 and 3.
Exactly. Super easy, right?
Yeah. So then the top one, I really just counted by sevens because it was 1, 2, 3, 4. So I just did 7, 14, 21, and 28.
Excellent.
Yay.
Another way we could have gone about it. Perfect. This is times 2. This is times 3. This is times 4. So the same way. Times 2, times 3, times 4. Exactly. Great job. Both ways work. We did repeated addition, which is the same as multiplication. Let's see number 2. So this problem says, Tonya ran 8 kilometers in 60 minutes. At this rate, how long would it take her to run 2 kilometers?
Alright, so what I did first was divide 8 divided by 2 and then the 60 divided by 2. And I got 4 and then 30.
Excellent.
But what we needed to figure out was how many she ran in, how much minutes she ran 2 kilometers in. So I just divided 4 and 30 divided by 2 once again. And this is 2. And this would have to be 15 minutes.
Excellent. Great work, Ben. These are also really easy to just go from the initial to the end because we can do that, but not always. We can't always do that. Let's see number 3. Who would like to do number 3? Who would like to? Romario, come on up here. So, the problem says, Lamika buys 12 packs of juice that are on sale and pays a total of $48. Use a ratio table to determine how much Lamika will pay to buy 8 more packs of juice boxes at the same store. So we have to fill out the whole table.
Right.
We have to fill out the whole table.
I think, what happened?
You went to the next slide, it's okay.
Oh, alright. I think you put like 12 right there.
So she bought 12 packs of juice, and how much did she spend?
Spent, where's the problem? $48.
So she spent $48.
Alright, so then what happened?
And we want to find out how much it costs to get to 8. Can we go from 12 to 8 with the whole number?
Yeah.
No. So, what do we have to do, Romario?
You have to divide the 12 by 4 and
Perfect.
equals 3, and then...
That's not... Well,
Oh, wait, no, I messed up.
let's see what we do. We're close to what we do.
I just mixed it around. Alright, so then divided by 3, and that's 4, and then go like that. And
But does that work on the bottom? Can we divide 48 by 3?
Yeah.
Then do it.
Okay, so then you divide this by 3, then it equals 16,
Excellent.
and then divided by 2.
Times 2.
Times 2 equals 32, and then
We did the same at the top.
Yeah.
Exactly. Romario nailed it. Exactly. There's also another way we can do this, following our unit rates. So in this case, we could go down to 1. How do we go from 12 to 1? We divide it by, Rocco, 12. What's 48 divided by 12? What's 48 divided by 12? Michelle, 4. And then, how do we get from 1 to 8? Times, Lily, 8. So we multiply this times 8, and we get 32. Same answer. There's multiple ways to go about this problem. I like what Romario did because he found the greatest common factor between the two. He found the greatest common factor. We have 148. We have 2, 24, 3, and 16, 4. Well, technically the greatest common factor is 12, but 4 made it easier on our lives. But it doesn't matter. There's all sorts of things to do. There's multiple ways to do this with scaling. We can do it with unit rates, or we can do it with other rates. There's multiple ways to go about this. So I want you guys to try number 4 and then move on to your homework. So, how can you determine if 2 ratios are equivalent? Who knows? How can you determine if 2 ratios are equivalent? Fernando? Yeah, if you divide them by the GCF and they get the same ratio. And we can divide things by all sorts of things, just like what we did earlier. So two ratios are equivalent if they simplify to the same ratio. For example, 1/3 to 6 and 3/9 are equivalent because they all simplify to 1/3. That was the first problem we did today. What about these ones? I'm going to ask you guys really quick. I'm going to ask you guys, are these ratios the same?
Yeah, the both one has. Yes, the both. No. Oh no.
Okay, so which ratio is not equivalent? Which ratio is not equivalent? Who can tell me? A new hand. I want to see a new hand. Gore. 7/15. And why is 7/15 not equivalent? Michelle. Exactly. All of them are equal to half, but 7/15 is not. How can I make 7/15? What could I change to make it equivalent, Lily?
You could change it to 7/14.
Yes, I could change it to 7/14. And now they're all equivalent. This is how we can do equivalent ratios. All of these are what scaling is. This is exactly what scaling is. So we might not be able to go from 4 to 9 with a whole number, or from 4 to 7, but we can go from 4 to 1, and then 1 to 7, or 1 to 9. Does that make sense? This is how we can use scaling. I highly advise, if possible, to use unit rates to scale, but if not possible, use the GCF. The homework is page 43 to 44, but make sure we already finished page 42, so we're all good.